All right, let's dive straight into this explainer. Today, we are unlocking the exact mathematical toolkit you need to manipulate shapes across a coordinate grid. And more importantly, we're going to look at the warning signs and common pitfalls that absolutely sink grades in Cambridge 0580 exams. You could think of this as the Shapeshifter's Toolkit. We are going to decode the specific rules that govern how shapes move, flip, turn, and grow, so you can lock in those top marks.
Here is our game plan. We'll start with the core transformation concept and then hit the four main pillars: reflection, rotation, translation, and enlargement before throwing them all together in combinations.
Okay, part 1, the transformation concept, changing position and shape. Let's get the foundation right.
So the absolutely crucial point here is mastering your vocabulary. Your starting shape is always the object, and your final result is the image. Listen, I see students all the time. Let's call a typical student Sam, who rushes through the exam, misses the command words, and mixes up the object and the image. If you do that, you're applying the transformation entirely backwards, and you lose all the marks for that question. Read carefully and identify the starting object first. Oh, and before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving on to part 2, reflection, the flip movement.
Think of reflection as just picking up a shape and flipping it over like a pancake. But here is the pitfall. You get students, let's call them Alex, who overload their answers with raw math facts, but completely fail to analyze what the examiner actually wants. To accurately describe this flip, you absolutely must identify the exact mathematical equation of the mirror line. It might be the x-axis, which is y equals 0. It could be a vertical line like x equals 2, or a diagonal like y equals x. If you just write down the shape flipped, you get 0. You have to define the exact line.
This brings us to the golden rule of reflections. Every single point on your image must be perfectly equidistant from the mirror line, and it has to be measured at a strict perpendicular right angle. So if your object point is 3 units away from the mirror line, your image point is exactly 3 units away on the opposite side. Always map at corner by corner using 90-degree angles. Counting those grid squares perpendicular to your line is what guarantees you nail the position every single time.
All right, part 3, rotation, the turning movement.
Now, rotation is a turning movement. It leaves the size and shape identical, but drastically changes the orientation. To get full marks, you literally cannot describe this movement without providing 3 precise parameters. You need the exact center point, the degree angle, and the direction of the turn. If you just write rotation of 90 degrees, the examiner's pulling out the red pen. You must explicitly state it's a rotation, give the angle, state clockwise or anti-clockwise, and give the exact coordinate for the center of rotation, like 2, 1.
Okay, part 4, translation, straight sliding movements. But wait, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get back into it. Translation is a straight, sliding movement. There is absolutely no turning or resizing involved here. The object just glides across the grid. These translations are commanded by column vectors. The top number tells you your horizontal slide, and the bottom number is your vertical slide. So a vector of 6/3 means every point moves right 6 units and up 3 units. If you see a negative top number, like -4/5, that means you slide left 4 units and up 5. It's a really elegant, strictly numerical way to command movement.
Let's look at part 5, enlargement, resizing the image. This one is a real game changer because unlike the other transformations that just shift things around, enlargement actually alters the size of the shape. It creates a mathematically similar image. And just like rotation, you need specific data to get your marks. You must state the exact center of enlargement, and you must provide the numerical scale factor. The scale factor dictates how much larger or smaller the image is, and the center tells you the precise starting anchor on the grid.
So, what happens when the exam throws a curveball? You're looking at a before and after grid. You have the object and the enlarged image. How do you mathematically locate that invisible center point?
The trick is incredibly simple once you know it. You just draw straight connecting lines through the corresponding points of both shapes.
You take your ruler, draw a line straight through the top left corner of the object and the top left corner of the image, and just keep extending it backwards. Do this for all the corners. The exact point where all those lines intersect on the coordinate plane, bam, you found your exact center of enlargement. It's a brilliant visual trick that completely decodes the math.
Now pay close attention because this is where a ton of students drop marks. You have to know the difference between a standard positive scale factor and a negative one. A positive enlargement projects the image outwards on the same side of the center, but a negative scale factor, like -2, literally throws the image backwards through the center point and it ends up inverted on the complete opposite side. Read the warning signs on these questions, guys.
Finally, Part 6, Combinations, Chaining Transformations.
Real exam questions don't usually stop at one basic movement. They make you chain them. The strategy here is to treat every single transformation as an isolated step. First, perform the enlargement to create an intermediate image. Draw it out lightly in pencil. Don't try to hold it in your head like our friend Alex might, or you will inevitably mess it up. Once that's drawn, take that new intermediate shape and apply the reflection across the line x = 1. Taking it step by step guarantees your accuracy. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
Ultimately, the entire coordinate grid is yours to command once you break these movements down into their basic tools. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.